What's up, everyone, and welcome to the Renewable Energy Smart Pod. I'm your host, Sean McMahon, and after taking a few weeks off to catch our breath after COP26, we're back for another episode. And my guest today is John Powers. John is the founder and CEO of Extensible Energy, a firm that is also part of the California Load Flexibility Research and Development Hub. CalFlex Hub, as it's known, works to develop energy efficiency and distributed energy resource technologies that are flexible, interoperable, and grid integrated. As more and more renewables connect to the grid, John and I will be talking about load flexibility and some of the technologies being deployed in commercial buildings to optimize energy usage and save businesses big money. As I mentioned, we did 3 episodes related to COP26, so be sure to give those a listen in case you might have missed them. And if the finance and reporting aspects of the ESG topics discussed in Glasgow are of interest to you, check out SmartBrief's other podcast, The Modern Money Smart Pod. That show tackles the way everyone from consumers to traders on Wall Street are trying to tackle the complexities surrounding ESG data and investing. Looking ahead, next week I'm going to be talking taxes with Sean Moran, one of the tax gurus from the law firm of Vinson & Elkins. Tax incentives like the production tax credit and the investment tax credit have had a massive impact on the growth of renewables, and the possibility of direct pay also looms on the horizon. Sean is going to join me to dive into what lies ahead for that corner of the renewables industry, particularly as projects in the U.S. expand into the realm of offshore wind. So let's get things going. But before John Powers and I start talking load flexibility, here's a quick word from the exclusive sponsor of today's episode, Emerson.
Emerson has a deep legacy of helping our customers in the world's most essential industries solve the most complex challenges of modern life. Our breakthrough software and technologies drive innovation that makes the world healthier, safer, smarter, and more sustainable. Emerson, consider it solved.
Hello, everyone, and thank you for joining me for today's episode of the Renewable Energy Smart Pod. Today, I'm joined by John Powers, the founder and CEO of Extensible Energy. John, how you doing today?
I just get better all the time. Thanks a lot.
Oh, that's a great way to look at life. Well, we brought you on the show today to talk about a few things. Number one, your firm's heavily involved in load flexibility and how that impacts commercial real estate and other buildings, but also because you're associated with the California Load Flexibility Research and Development Hub, which is otherwise known as CalFlex Hub, which is a prime contractor of Lawrence Berkeley Lab. So let's start with the basics. We have a lot of listeners for the show who might not be that familiar with load flexibility. So give me load flexibility 101. What is it?
Well, first off, thanks a lot, Sean. Really excited to be here with you today. Load flexibility, we view that as a platform for value for the customer and value for the grid. So we're really excited, of course, to see the adoption of solar and wind as the primary sources of new energy on the grid. But as the generation side of the grid becomes less dispatchable, the load side of the grid has to become more flexible. So load flexibility can provide demand charge management for customers, time of use arbitrage for customers, but it can also provide services to the grid that are necessary to accommodate a greater amount of non-dispatchable renewables on the grid. So that could be in the form of demand response, that could be in the form of participation in real-time load flexibility markets and everything in between.
So why is load flexibility so important to the grid of the future? Is it because all those renewables that might be coming online?
For sure, the renewables are the driving force for greater value from load flexibility. So, of course, we all think of energy storage as being a key enabler of more wind and solar on the grid, and it surely is. But in addition to that, there's storage available in residential, commercial, and industrial buildings or customer-side resources that are much cheaper than expensive new fixed battery storage. And being able to tap into that storage, for example, the natural flexibility of when electric vehicles charge or the natural flexibility of the thermal mass of buildings, any of that is cheaper than buying new batteries just for the grid.
And I mentioned at the top that Extensible Energy is part of the CalFlex Hub consortium of companies. So what is CalFlex Hub doing to develop the technologies needed to optimize all these smart buildings?
Yeah, that's a great project that the U.S. Department of Energy and the California Energy Commission are funding. with Lawrence Berkeley Lab as the prime, and we're a small part of the project as well, to pioneer price signals that enable customers to benefit from load flexibility. So it's great to have information on prices flowing from the wholesale market to the retail market, all the way down to the end customer, and demonstrating that customers really can provide load flexibility back to the grid in response to price signals. So the CalFlex Hub project is certainly an R&D project in that it's developing some of the technology for those price signals, but it's really a demonstration project to get that technology pushed all the way down to real buildings in the real world and demonstrate the value to the end customers. So that's our piece of it, as we specialize in small to medium commercial buildings, and we'll be controlling those buildings in response to the price signals generated through LBL and its other subcontractors.
So what do some of those technologies look like? Technologies being developed that'll be installed in commercial buildings. What are we talking about?
So the technologies we're working on are all about control of flexible loads in commercial buildings. That could be batteries and that could be car chargers behind the meter. But in most buildings, that's heating and cooling. That's the largest flexible load in almost all commercial buildings. So we have our DemandX software, which controls the flexible loads in, almost any kind of commercial building: office, retail, church, school, conditioned warehouse, municipal building, any place where there are large flexible loads behind the meter. Our gateway talks many different languages to all the different types of loads in buildings. The most common is to thermostats or to existing building energy management systems. None of those systems are built to respond to grid signals, particularly today. So our piece is to be able to tell the loads in the building when to use more energy. We always used to talk about energy efficiency, and energy efficiency is mostly about hardware. But load flexibility is about software, because when you use electricity is just as important as the total amount of electricity that you use. So we say, hey, it's okay for this part of the building to be a couple degrees cooler right now. Hey, it's okay for this part of the building to be a couple degrees warmer right now, because that is a lot of energy that can be moved from minute to minute and hour to hour without affecting the comfort or the convenience of the customer or the tenants in the building. So if you can shift load from hour to hour, you can benefit greatly from existing tariffs just through demand charge management, but certainly even more greatly from the opening of load flexibility markets similar to those being explored with the CalFlex Hub project.
How does the CalFlex Hub work mesh with the build out of more renewables? Are they kind of specifically going for solar and wind and battery kind of build out, or is it more legacy power generation sources?
No, I think that the CalFlex Hub anticipates all of the other state and national goals for increasing the percentage of renewables on the grid, and is working to quickly help the load side catch up with that. So the solar is coming, the wind is coming, and the CalFlex Hub project is designed to help the load side catch up with what's happening on the supply side. The supply is getting cleaner and more renewable and more distributed all the time. We're already curtailing a lot of the output of renewable resources today in California because there's no demand for it at certain minutes or hours during the day. So being able to match the load with the generation is a key piece of what the CalFlex Hub project is all about.
And so how does that smart building technology interact from the utility side? They're looking to develop minute by minute power pricing. Where is that intersection going to happen?
Well, in part through a price server that will be part of the CalFlex Hub project, and then in part in our software, which will react to those prices to say, as I was mentioning before, now we see prices are cheap. It's a good idea to pre-cool part of the building or pre-charge a battery or pre-charge an electric vehicle behind the meter. Oh, and now a little later, power is becoming more expensive. It's a good time to let the temperature drift back up a couple degrees. Again, this is all stuff that happens automatically. No end customer has to jump into the cockpit of their energy management system and fly it all day because nobody wants to do that. Our software uses machine learning, artificial intelligence. This is one of those cases where artificial intelligence is taking away jobs that no one is doing. So no one is actually watching minute by minute, hour by hour, what the price of electricity is and what the hundreds of decisions that need to be made in your building would be. So the software takes care of all of that for you. It's a great way to sort of begin to understand your current electricity bill, how you can control what was previously viewed as uncontrollable. Most commercial buildings view electricity or energy in general as an uncontrollable line item expense. We bring the ability to do more control and to get control of your electricity budget. And that's important today, but it's going to be so much more important as prices get more complicated and more variable as we bring more renewables onto the grid.
Does the build out of EV and electric vehicle charging stations, does that complicate this system at all? Because, what I'm seeing is that some building will line up 8 or 10 EV chargers outside. Employees drive up, plug in. So obviously that's charging during the working hour of the building. So how is that adding to the complexity of this?
Well, in some cases, we like to say the more complex, the better, because there's less and less opportunity to adjust to this stuff manually. Existing building management systems are paying no attention to what the prices on the grid are. They're paying no attention to what new changes to the electrical infrastructure of the building, like putting in new car chargers, are. You need software that's dedicated to watching the whole building usage and the individual components of that usage. So yes, it makes it more complicated for an existing building to manage its loads, but it just drives up the need for software like DemandX, which can monitor all of that with no more difficulty than it's monitoring the heating and cooling loads today. So we built it for that purpose. So as we add more car chargers, batteries, basically as we electrify everything and clean up the grid, you need the ability to respond to grid signals and manage more and more complex loads in a building.
Yeah, I like what you said there about this is another example of AI, taking a job that no human's doing. That's pretty good.
Thanks. Yeah, I have to say that you certainly could imagine humans doing this, but it rapidly becomes infeasible to make the hundreds of decisions a minute throughout the building to really optimize the usage patterns of the building. We're talking about really meaningful savings for the end customer as well. With the rate structures that are, even those that are in place today, you could be talking 15 or 20% of the electricity budget of a building just by shifting usage patterns around a little bit. And as we add more, as you just mentioned, more and quite significant electrical loads to a lot of buildings, I think folks are going to be faced with some sticker shock with their utility bills unless they can manage them more automatically.
We're going to take a quick break, but when we come back, we'll hear John's thoughts on how the adoption of smart building technology might resemble the adoption of mobile phones.
As a global innovator, Emerson has a deep legacy of helping our customers in the world's most essential industries solve the most complex challenges of modern life. Powered by a community of problem solvers with industry-leading expertise, we deliver sustainable grid solutions that increase efficiency, reduce emissions, and conserve resources. Our breakthrough software and technologies seamlessly integrate renewable and distributed energy resources into the power network for a more reliable and stable electric grid. We drive innovation that makes the world healthier, safer, smarter, and more sustainable. Emerson, consider it solved.
And now back to our conversation about load flexibility and smart building technology with John Powers from Extensible Energy and CalFlex Hub. So how fast does the messaging come? How fast does it go from, say, a wind farm 50 miles away that suddenly wind has died down? And a lot of the critics of wind say it's so intermittent. So, okay, at 3:30 in the afternoon, the wind dies down 50 miles away, obviously, so there's less power available. How fast does that message get to the building that has this software involved? So it knows, okay, hey, let's back off of a couple degrees of HVAC or something like that.
Right. So there's a couple of components to that. I think the signal can get to our software in the cloud almost instantaneously. We don't mess with thermostats or other things in the building too frequently because you don't want to break the compressors. You don't want to be turning stuff on and off every minute. So we basically do a sweep of the building about once a minute just to see what everything is doing. But we send signals that change the state of particular devices only as frequently as necessary to keep the building comfortable and to beat the sort of 15-minute interval pricing that most of the customers are on now. So it's typically on the order of a minute to go from a signal to a change in the building. And again, you want to be judicious about how frequently you change any one device. So you change the set point of a thermostat, that will change within a short amount of time, not instantly, but that will change what heating and cooling units turn on for a given period of time. Even sort of that loose level of control of just changing set points allows you to shift energy quickly enough to adjust to any change in pricing on the grid or to adjust to a current demand charge. Right now, so you and I pay for kilowatt hours at home, right? Just how much energy we use, we get charged by the kilowatt hour for that. And commercial buildings get charged for that too, but they also get charged based on the highest 15 minutes of usage during the entire month. So that's called a demand charge, and that can be up to half of the utility bill for commercial customers. So if you think about that for a second, that's like saying the worst mistake your building makes all month long can be half your bill. So we try and make less bad mistakes. We try and make the worst mistake of the month less bad, and that can save you a ton of money on your electricity bill.
So what kind of feedback are you getting from customers who've either deployed this technology or from some who haven't yet, why they might be waiting?
Yeah, so the feedback's been great. We do voice of the customer analysis constantly because we're trying to improve the product and respond to what customers need, because it isn't all just about cost, right? We've had customers tell us that there's basically 4 C's in a building. There's comfort, control, cost, and carbon. And we have customers who react to each of those components to a greater or lesser extent. Some are just in it to control their costs, and that's sort of what our original vision of the product was, that this would be something for helping businesses save money as the grid becomes more complicated. But we have just as many customers who are following their own corporate sustainability goals, who are using this as a way to reduce their carbon footprint, shifting their usage from dirty times to clean times on the grid makes a big difference. And we have customers who are definitely much happier about the comfort once they get their whole building under better control. So that you've, I'm sure, heard about thermostat wars and other sort of things in commercial buildings where everybody has sort of a different tolerance for being warm or cool at a given time. Well, we can guarantee to keep the building within a range of temperatures that everybody agrees on ahead of time, and then allow customers to override when they have to for special events or something like that. That gives them greater control over their own comfort and cost and carbon. So folks tell us that the buildings are more comfortable after we got there than before. They are definitely under better control. So we have customers who tell us, I was just worried that, my employees were leaving the air conditioning on a Sunday when we weren't even open in the building. So there's some just really simple improvements that you can get from getting the building under better control. But once it's under better control, you can react to signals from the grid. You can react to, your own schedules and needs too. So we're getting a good feedback from the customers about what we've done so far. We're improving our reporting so we can track the savings better and track the carbon savings as well as the energy and dollar savings. And we're doing more through CalFlex Hub and other initiatives we have going to respond from signals from the grid as well.
All right. And then, so you mentioned the reporting, carbon savings and reduction and things like that. So do you see this as a growth area? ESG is everywhere, right? And a lot of companies are going to be trying to do a lot more reporting. So does this factor into that as well? Like a company can say, hey, we actually have data on how much less carbon we're using.
Absolutely. It's a key input. Energy usage is a big input to any of the carbon footprint tracking that customers are doing. ESG is a much bigger topic than we cover in our software. We're focused on the energy components of that, but it's a key input and it's something that can be tracked and measured minute by minute, hour by hour. We have a partnership with WattTime and RMI, which WattTime is part of RMI, and they track the carbon intensity of generation at a very fine-grained level across all the different wholesale markets in the United States. So we work with them to track the carbon intensity of usage in each of our buildings and, reporting on that and helping our customers meet their ESG goals is, for some, it's not a big priority yet, but for others, it's a key buying decision, buying criteria for the software.
So you mentioned a lot of customers are trying to decide whether to make this kind of investment in this technology. So what are you hearing from customers who might say that they're very interested, but they just want to wait? What is it that they're waiting for?
Yeah, that's a great question. I mean, a lot of what we're doing is trying to reduce the complexity so the buying decision is easier. A lot of folks do not think about energy as their top priority. So we have been focused on making this one-day installation, simplifying our pricing, simplifying the implementation on the customer's end so that there's really no reason to wait. The payback time for most customers is less than a year. So basically, it's a very high return on investment. So it's really an attention thing. So if they're paying attention to energy at all, we don't usually get folks who want to wait. But if energy is not their top priority, we've run into plenty of customers who have supply chain issues or employment issues that sort of trump any of the energy concerns, and we'll be ready when they are on that in those cases.
All right, you mentioned the payback time is usually less than a year. So who are the customers or the building owners who benefit the most from this right now? Where's the most business booming for you?
The software pays for itself anywhere today where demand charges are above maybe $8 to $10 per kW. That's about 2/3 of the country. So we're getting a lot of interest here in California, get a lot of interest in Colorado because we've got a great partner out there who's done quite a bit of business with us. We have interest, though, from really, I'd say, at least half the states and 2/3 of the population of the country. So we had folks in Florida, folks in the Northeast. Demand charges are high in the Northeast. So there's a lot of different pockets around the country where this is very interesting to people. Our biggest two markets right now are California and Colorado, but it's growing all over the country.
All right, you got ahead of me, John. I was going to ask you that question next about any geographic areas where you're seeing a lot of business. So let me just change that to then what kind of industries? I mean, you mentioned supply chain, things like that, but are there any industries where they're calling you now, realizing how much sense this might make for their operations?
Yeah, so retail is big for us because the ability to drive costs down really helps in a thin margin business like retail. We're working on some bigger deals in the office sector because unlike a lot of these technologies, this will work for tenants as well as owner-occupied buildings. So a lot of sort of heavier retrofit work only applies to places where there's a kind of owner-occupied or particular metering structure from the utility. Our software is, it's software. You don't need to do a lot of equipment retrofitting or anything else. So a tenant with more than a 3-year lease can see a rapid payback and be able to implement this without any interaction with the landlords at all. So we're seeing some more interest in offices. We've had a lot of interest from schools who have recently gotten money out of either federal or state infrastructure bills. And in particular, since a lot of our software affects the HVAC systems, there's some incentives now to upgrade controls on HVAC systems that schools have approached us about. That's a great market for us. Solar-equipped schools, especially interesting because solar takes care of a lot of their energy, but not demand charges. So being able to reduce demand on a solar-equipped school has a really quick payback time and can really help with the mission of solar in those buildings. We make the best use of solar by really increasing the savings and increasing the carbon savings from going solar. So those are three of our biggest: retail, office, and schools.
So I was bouncing around the CalFlex Hub site, and it seems like they have their eyes on a just transition. And so they mentioned how they're, in addition to developing all this technology, they're also keeping their eye on providing it to disadvantaged and low-income communities that might not be able to afford it. So how does that function? What does that look like?
Yeah, we take that very seriously. We're really proud of some of the work we've done with houses of worship in underprivileged areas. Savings of even a few $1,000s on their electricity bill just translates into more available for their mission in the community. We work with a church in Bakersfield that distributes food to families throughout a relatively low-income community there. It just frees up more resources that are needlessly going to utility bills, frees up those resources for their mission in the community. Same with schools. There's schools that have very stressed budgets that they'd love to see that money go into the classroom rather than off to the utility. The ability to have a low-cost, simple-to-implement solution that helps reduce the utility bills of any of these kinds of organizations really is going to speed the adoption throughout the community, not just in the biggest, richest buildings, but through the just transition we all want to see, the electricity transition or the energy transition support.
So John, as someone who's been on the front lines of the development of cutting-edge energy technology for quite a while, do you have any bold predictions about what smart building technology will look like in, say, 5 or 10 years?
Yeah, I think the smart building world and the smart grid world are kind of coming together. And while some of this technology has been available for a while in sort of big, rich buildings, think back to when cell phones were only available to rich people with their car phones and how things changed as we all got smartphones in our pockets. I think you're going to see things that were only available to the biggest, richest buildings become way more democratized and distributed to every small to medium building on the grid. And I think that's going to really expand the number of applications that I talked about earlier that are available to everyone on the grid from a perspective of energy savings, demand charge savings, but also direct participation in load flexibility markets like we talked about with CalFlex Hub. So I think the change is going to be pretty quick and pretty extreme compared to the cell phone transition. And I think it's going to really help the customers save money and the grid to clean up and electrify everything.
Well, that certainly sounds like a promising and positive prediction there, John. So I appreciate it. And I really appreciate your time today. I've enjoyed our conversation, and I know our listeners will too. Thank you.
Thanks, Sean.
Well, that's our show for today. But before we get out of here, I just want to say a quick thank you to the exclusive sponsor of today's episode, Emerson. If you like this podcast, please share it with your friends and colleagues. And be sure to follow us on Apple, Google, Spotify, or wherever you get your podcasts. You can also follow us on Twitter, where our handle is @RenewablesPod. And if you'd like a daily dose of renewable news delivered to your inbox, head to smartbrief.com and sign up for the Renewable Energy Smart Brief. The Renewable Energy Smart Pod is a production of SmartBrief, a future company.